Hello everyone, welcome to Devs Assemble. In this video, we are going to talk about what is hashing and how it is used in blockchain to maintain the integrity of the data. As you have probably realized, the blockchain can contain lots of information and it just keeps getting bigger and bigger or longer and longer. So the question arises, how are these nodes able to determine when a block has been changed and validate the integrity of the entire blockchain? It seems like as the blockchain gets bigger, it's becoming more and more difficult to do that. So what can we do now? We can use something called hashing for that. So a hash is basically a one-way mathematical function that's very easy to calculate but very difficult to reverse. What this means is that you can easily generate an output using the given inputs, but it's very difficult to figure out the inputs used in the calculation just by looking at the output. Let's take an example of a very simple hashing algorithm. Let me tell you, this is just an example to understand the logic and it's never really used in the real world. Let's just use the word hello. Well, how do we represent hello in some way that we can do some math on it? First off, we have to represent each character as some number. Well, fortunately, there's a standard table that does that for us. We will use the ASCII code. Computers don't store characters, they store numbers. So the ASCII code is a way of relating numbers to every character that you can print. It stands for the American Standard Code for Information Interchange. But don't worry about that, it's just a table. It means that letters such as A have a specific values with a number representation. So let's take a look at our ASCII table and we find out that H has a value of 104 and E has the value of 101. So we find the values for each letter in our string. Our function hash function here, as it's a very simple one, we are just going to add all of the numbers. So using our hashing and function, we can say that we can represent the string hello as the value 532. 532 represents hello, and it's kind of a difficult to look at number 532 and then figure out what the string it represents. However, with simple algorithms, you run into collisions. For example, what if we change our string a little bit? We change the first character to F and the middle characters from L to M. Now we have the new word FEMO. If we add up the ASCII values of this string, it's also equals to 532. That's what we call a collision. So a good hashing algorithm is the one which is very complex, fast to calculate, and nearly impossible to reverse and creates unique output for every input with very few collisions. In real world applications, we use highly complex hashing algorithms such as SHA-256. Let's see a real hashing algorithm in action. We will go to the website andersbrownworth.com. I will attach the link in the description for you. So here we have an example of very popular hashing algorithm called SHA-256. So what happens is as we enter the data, the hash will be calculated and updated here at the bottom automatically. We can see a big string of 64 characters over here. So let's type the word hello. We can see it's pretty fast. It's so fast that it keeps on generating new hash values as we are typing. So you can clearly see if I give you this hash, you will never be able to figure out that this hash value represents the string hello. It's pretty hard to do. So that's basically what hashes are all about. So now let's look into how hashes are used in the blockchain. The way it works is when you start a brand new blockchain, you actually start with one block and it's called the genesis block. In computer science, we start things at zero. We don't start counting at one. So the genesis block is the block 0 and the next block is actually the block 1. Now if I open the block, we could see a few details over here. Please note that this is just a simplified explanation and we will keep on going deeper and deeper as we learn. So the first one is the block number or the block sequence. The next one is the current block hash. We get this hash value when we put all the data of the block into the hashing algorithm like the one which we have seen before and it produces a hash value for us. So this block's hash is stored in this section. Now the next one is previous block hash. Here we will store the hash value of the previous block in the blockchain. In the case of Genesis block, it will be empty as this is the first block. Now the last one is the body which actually contains all the transactions detail or the data. Now let's see how we are building the chain of the blocks using these details. Here we have a first block called the genesis block with all the required data filled. Now we have added a new block to the blockchain. We follow the same procedure and calculate the block 1's hash value. After adding the block to the chain, we will update the previous block hash section of the block 1 with the hash value of the block 0. We will do the same when we add another block B2 and update the hash value of block 1 on the block 2. Let's say someone tries to change the data or the transaction details on the block 1. Then as we have already seen that even with a change in a single character, the hash value generated is totally different. So the new hash value is generated and updated on the block 1 automatically. As soon as the hash value of the block 1 changes, it will obviously mismatch with the block 2's copy of the hash value of the block 1 as per the old data. This will break the chain, and because of the way that every block's hash value points to the previous one, it actually breaks all the other blocks that comes later. So the key to blockchain integrity is finding the right hash value that makes verifying blocks very easy, but changing them very hard to do. That's pretty much about hashing in blockchain. Here's a quick summary. Hashes are a mathematical function that only works in one way. They're easy to calculate but difficult to reverse. Collision or hashes that creates the same result can be avoided by using complex hash functions. Any change in the hash data will change the hash result. The genesis block or the block 0 is the first block in the blockchain. Each block is linked by storing the previous block's hash. If the data in any block is changed, it changes its hash value, thus breaking the link to the block after it. This is how we can tell if any data has been changed anywhere along the blockchain. If you like the video, please don't forget to hit the like button and subscribe to the channel to get the latest update. Thank you for watching. See you in the next video.